Hi everybody. In this video, I'm going to show you, kind of explain a little bit about what you need to do for this project number one, rolling two dice. All right. So consider the following frequency distribution. Number one, I want you to draw a similar distribution below on a piece of paper. So draw a table, look just like this on a piece of paper. Okay. And once you draw it, and this is where you're going to start making your recording and answer the question. All right, list all the sample space for the sum of two dice onto the distribution you drew on the paper. So sum of two dice. So that should be, so on a piece of paper, you should roll the very first sum of two dice should be 2, right? And if you roll a 6 and a 6, then the last sum of two dice should be a 12. So the sum of two dice should be from 2 to 12. Okay, so once you roll that down, take a pair of dice and roll 100 times. You gotta have two dice. Okay, drop two dice, on the ground, in a box, whatever. Okay. All right, take a pair of dice and roll both of them 100 times. Okay, roll both of them at the same time. So that will be one roll. Roll 100 times and tally after each roll. So let's say the first roll you got a 1 and a 2. So that would be the sum of 3. So you tally 1. Okay, so do that for 100 times. So you will have tally all of them. Okay, so once you finish and tally all, the 100 rows you have, then you write down the frequency and you write the relative frequency over here. So if you only roll a sum of 2 5 times out of the 100 row, then your frequency will be 5. Your relative frequency should be 5 out of 100. So make sure you write it down on your on this table you drew. So once 100 row is complete, record the frequency. All right. And then after the frequency, you will find the relative frequency. Do not do not simplify your fractions. Okay. So if you roll 5 for the sum of 2, then your relative frequency will be 5 out of 100. Don't simplify your answer. Okay. All right. So after you finishing tally everything, you done, you fill out your distribution table, then you will just inside this box, you just write yes. Okay. So now question number 2, you based on your experiment, enter the relative frequency for the sum of two dice from 2 to 12 as a fraction. So whatever you wrote on the piece of paper for the relative frequency, I want you to write it here. Use graphical equation. Okay. So this is what you do. So my example earlier, let's pretend you roll the sum of 2 5 times. So here on the graphical equation, you will just write sum of 2. You just say equal. You roll 5 times, so it'll be 5 out of 100. Click on insert. Okay, press enter. Now you go back to graphical equation for the sum of 3. However many times that was. Okay. Enter sum of 4, sum of 5, sum of 6. Keep on writing it. So don't enter your answer in one graphical equation. For one row of the answer, that will be one graphical equation. For the second row, that's another graphical equation. Otherwise, you're not going to even see, and I might not even see what you entered. Okay, so do that for all the way down to 12. Okay, so the last one should be the sum of 12. Whatever you roll, okay, use a fraction bar, however many times you roll out of 100. Okay. All right, question number 3. Based on your experiment, enter the sum of two dice in L1. So based on your experiment, the sum of two dice from 2 to 12, you will enter them in a calculator under L1. And frequency, enter the frequency in L2 in the graphing calculator. So just like what we talk about in the lecture videos, okay, you'll put the sum of two dice under L1 frequency under L2 and use your graphing calculator to find the simple mean and the simple standard deviation. So use graphical equation. Here you will say for your simple mean, which is X bar. So we will come over here, look for X bar. All right. Outside of the box equals, see, there you go. Your X bar is so much. Okay. And then your simple standard deviation, which is lowercase s. Your simple standard deviation S is equal to so much. Okay. Round to 3 decimal place for your simple mean and simple standard deviation. Now, question number 4 is listing all the possible simple space for the sum of 2 dice from 2 to 12. Okay. Separate your answer with a comma. So I'm gonna do one for you, okay? So you can get idea. Let me do the sum of 3. Press another enter. So very similar to what you did earlier, sum of 3, okay? So list a possible simple space. So when we roll 2 dice, how can I get a sum of 3? You gotta be one, roll a 1 and a 2, okay? So 1 comma 2, double space, 2 comma 1, right? If you roll a sum, if you got 1 dice says 1, 1 dice says 2, that's a sum of 3. If you have 1 dice says 2, then 1 dice says 1, that's a sum of 3. And insert. Okay, so do that for all the sum from 2 all the way to 12. List all the possible simple space. So from the correct answer, you just enter in number 4, enter the total possible outcomes for the sum of 2 dice. So you can count how many, you can, if you actually count them, and we discussed this in the lecture video, you should know what is the total possible outcome for rolling 2 dice. All right, from the correct answer, number 4, which sum listed has the most possible simple space? So look back, what you enter here, which sum has the highest has the most simple space? All right, question number 7, if 7 or 11 occur on the first row, the player wins. What's the probability of winning on the first row? Okay, so think about what you listed over here in question number 4. Okay, to answer that question. Same thing with number 8, rolling a pair of 1s is called the snake eyes. What's the probability of losing a dice game by rolling a snake eye? So think about what you enter here for question number 4, okay, and a total possible outcome to actually answer this question. So that's pretty much it for this project. I just want you to actually do the experiment yourself, rolling the pair of dice 100 times and see what your frequency, relative frequency are, and compare that relative frequency to what is an actual, okay? And looking back with question number 4 and looking at what should be, okay, the number outcomes, okay? Alrighty.